Hello everyone, today we're talking about rational functions, specifically our slant asymptotes, and we're going to go all the way into graphing these rational functions. So the second part of 3.6. This example here, they want us to find the intercepts and asymptotes and then sketch the graph. So, like we did the first part of 3.6, x-intercepts are the zeros of the numerator, so let's go ahead and factor. So I can pull a 2, so that leaves me with x squared plus 5x plus 6. And I can also factor the denominator to be x plus 2, x plus 1. Numerator can again simplify a little bit further. So if I simplify a little bit further, that's actually going to give me 2 times x plus 1, x plus 2, x plus 3, divided by x plus 2, x plus 1. Well, here we can see we have a common factor, x plus 2, so we're going to have a whole when x equals negative 2. And when we get to the graph, we'll actually see what that whole looks like. So our x-intercepts are the zeros of the numerator, so the only x-intercept being x plus 3 equals 0, so x equals negative 3, so my x-intercept is the point negative 3, 0. Next, I'm going to do my y-intercept. And remember, my y-intercept was when I just plug a 0 into the graph. I'm going to plug it in right here since I already canceled those factors. So that gives me 2 times 0 plus 3 divided by 0 plus 1. Well, that gives me 0 plus 3 is 3 times 2 is 6 over 1. So that gives me 6, meaning my y-intercept is the point 0, 6. So here I've got my x-intercept. Here I've got my y-intercept. Nothing new. We did that last lesson. Let me move this down a little bit. Next thing we have to do is find our asymptotes. So vertical asymptotes are the zeros of the denominator. So here we can see we have our factored form. So the only denominator, only thing we have to worry about is the x plus 1. So that means our only vertical asymptote is x equals negative 1. Next, horizontal asymptote. So horizontal asymptote, we look at the total degrees of the numerator and the denominator, the largest degree of the numerator and denominator. So these are both 2. So we just do the ratio of the leading coefficients. So there's a 2 there, there's an imaginary 1 there. So that means we have a ratio of 2 to 1, meaning our horizontal asymptote is the line y equals 2. Yes, you must write the line y equals 2. You cannot just say the horizontal asymptote is 2. The horizontal asymptote is y equals 2. The vertical asymptote is x equals negative 1. Okay, so here we have gotten a lot of the parts we need for the graph. Last thing we're going to do is we're going to make a table of values. So we know what the graph is doing at each different point. So along the top, we're going to write our critical numbers. These are all of the values that we get for x. So we got x equal negative 3, we got x equal negative 1, and we had x equal negative 2. Right? So those 3 values are all very critical in terms of our x. Right? So all 3 zeros for our x. Next, down the side, we put our factors. So we had the factors x plus 3 and x plus 1. I don't put the factor x plus 2 because it canceled. But negative 2 is still an important critical number in terms of the graph. Right, that's why I do put the negative 2 here because it's a critical number, but I don't put the factor here because it canceled out. So then I do draw my line underneath my critical numbers. And to find the sign, all I'm doing is finding the sign so I can see where the graph is going to be in each location. If I plugged a number less than negative 3, like so a number more negative than negative 3. So if I plug negative 4 in, for example, negative 4 plus 3 is negative 1, so it's going to be negative to the left of negative 3, so this one's definitely going to be negative to the left of negative 3, but overall, that gives me a positive value for my graph, because negative divided by negative is a positive. Okay, I go to the next section. I'm looking in between negative 3 and negative 2, so maybe negative 2.5. Negative 2.5 is not going to make this negative because the 3 is larger, so it's going to be a positive value. However, negative 2.5 is greater than negative 1, so that would make that negative, meaning the overall sign will be negative in between negative 3 and negative 2. These are my x values. In between x equals negative 3 and x equals negative 2, my graph will be negative. Okay, again, I look in between negative 2 and negative 1, so negative 1.5 falls in between there. Negative 1.5 is not large enough to make 3 negative, so that's going to be positive. But negative 1.5 is large enough to keep this negative, so that's going to be negative. Overall net effect, negative. And anything greater than negative 1, let's plug in 0, because 0 is greater than negative 1. 0 plus 3 is going to make this positive. 0 plus 1 going to be positive. So my graph is positive once my x values get larger than negative 1. So I'm going to show you the general sketch using my table here, my signs table that they call it. When I'm using the signs table, I'm using my asymptotes, I'm using my intercepts. All that information I'm going to put on my graph, and then this will tell me how my graph looks in each of these different sections. So first, I found my x-intercept to be negative 3, 0. Okay, so my x-intercept is there, my y-intercept is 6. 0, 6. Okay, then I've got a vertical asymptote at negative 1. So at negative 1, when x equals negative 1, I've got this vertical asymptote. Then I have a horizontal asymptote at y equals 2. And we show asymptotes with a dotted line to show that they're not part of our graph. They just kind of give our graph boundaries where they won't cross. Then I use my signs table. Okay, so when my x goes from negative infinity all the way to negative 3, I'm positive, right? So my graph, I'll do it in this color, my graph is going to be positive as far negative as I want to go. So from negative infinity to negative 3, my graph is positive. That's why I have the positive sign here. It's positive, right? And that was all values less than negative 3. Okay? Then in between, when x is negative 3 and negative 2, I'm negative. Okay, so I'm going down, and when x reaches negative 2, we have a key thing here. We have a hole when x equals negative 2, right? Because the factors cancel. So we have a hole in our graph right there. And then from negative 2 to negative 1, so in between when x equals negative 2 to when x equals negative 1, we're going to go and we're going to approach this asymptote, never crossing it. So this part of our graph looks like this. Rough sketch. The top part of our graph, right, because we're going to have two parts, we have to worry about the numbers that are greater than negative 1. Well, whenever my graph is greater than negative 1, all my values are positive. And our graph, if you want to think, it's kind of like it gets sucked towards the asymptotes. Okay, so they're gonna approach these asymptotes, but never actually touch them. So if you want to think that your graph is always going to have to end up going towards your asymptotes. So our rough sketch looks like that, using our signs table, using the information that we did from section 3.6, the first part. And all we did was take that information, put it on a graph. So to give you, this is what the graph looks like cleaned up a little bit, but you can see that we've hit all the same points. We've got the same asymptotes. And I just wanted to show you what a cleaned up graph looks like. Ours will look better than mine. I'm doing it kind of quickly just to get you guys examples, and then we can spend a little more time in class working on them going a little bit slower. So if you need to go back, recheck any of that, where I got any of that information, pause it, go back, make sure you're cool with it. And then we're going to work on another example. Now we're going to start dealing with slant asymptotes. So the last one had a regular vertical, regular horizontal, regular x-intercept, regular y-intercept. It had the hole, which we showed. And this one now is going to have a slant asymptote, but we're going to work the same way as before. So first thing I'm going to do, factor. We have an x in common. And x plus 1 is already as factors as it's going to get. So my x-intercept, 0 is in the numerator. So x equals 0, or x minus 1 equals 0. So that means x equals 0 gives me the point, gives me the x-intercept, 0, 0. And when x minus 1 equals 0, that means I get the intercept 1, 0. So we got two intercepts, two x-intercepts in this example. Y-intercept. Plug a 0 in for x. Well, if I plug a 0 into the top, I get 0 times 0 minus 1 over 0 plus 1. So overall, that gives me 0 divided by 1, 0. So that means my y-intercept is 0, 0, which I already knew because I found it up here. So that gives us the three intercepts, really only two, 0, 0, and 1, 0. Then the next step is to find the asymptotes. So I'm going to start with the vertical asymptotes. And remember, vertical asymptotes are just the 0 of the denominator. So we started off with x plus 1 in the denominator. So that means my vertical asymptote is the line x equals negative 1. And my horizontal asymptote in this case means I just look at the degrees. Well, we didn't have many examples of these in the first lesson, but when we did, the numerator has a larger degree than the denominator. Right? The numerator has degree 2, the denominator has degree 1, so that means I do not have a horizontal asymptote. And last lesson, we just stopped there. We didn't know what further to do, but now we do. A slant asymptote, to find the slant asymptote, we just do synthetic division. Right? So we actually take x squared minus x and divide it by x plus 1. So if I use synthetic division, x plus 1 gives me the 0, x minus 1. And I had a positive 1 x squared, a negative x, and I didn't have a constant term, so I have to fill that spot with 0. So now go ahead, pull my 1 down. 1 times negative 1 is negative 1. Negative 1 plus negative 1 is negative 2. Negative 2 times negative 1 is positive 2. Leaves me with the remainder of 2. Alright, cool. So, if we were to write this out, we would get the line y equals x minus 2. And whenever we're dealing with slant asymptotes, I'm not worried about the remainder. All I'm worried about is the line that remains. So this line, y equals x minus 2, is going to be a slant asymptote. So it's going to help us, it's going to help guide our graph. And it's going to be a slant, it's going to be, a slant instead of a horizontal. And you'll see when we get to the graph what that slant asymptote looks like. Before we get to the graph, again, we have to create our sine graph, our sine table. So we had critical numbers for x. We had the critical number negative 1. We had a critical number 0. We had a critical number positive 1. So negative 1 came from the vertical asymptote. 0 came from one of the x-intercepts. 1 came from the other x-intercepts. So those are our critical numbers. Those are the ones where x make the graph equal to 0. And then we have our factors. We had the factor of x, right? When we factored it out, we had this factor x. We had the factor x minus 1, and we had the factor x plus 1. Okay, and now draw your line below your critical numbers so we don't get confused. Now, if I plug in a number less than negative 1, I'm going to pick negative 2. So if I plug in negative 2 for x, well, that's obviously negative. If I plug in negative 2 for x minus 1, that's going to give me negative 3, so still negative. And if I plug a negative 2 in for x plus 1, I still get negative 1, meaning I get negative. So a negative divided by a negative is a positive, divided by another negative means my overall net will be a negative. Okay, again, I go on to the next one. In between negative 1 and 0, I'm going to pick negative 0.5. So negative 0.5, if I plug it in for x, is negative. Negative 0.5 minus 1 is negative 1.5, so it's negative. And negative 0.5 plus 1 is going to give me a positive 0.5. So overall, negative divided by a negative is a positive. Divided by a positive is a positive. Now I'm going to pick values in between 0 and 1. I'm going to pick positive 5, or positive 0.5. So just here, I'll put in red the numbers I used. I used negative 2. I used negative 0.5. Now I'm going to use 0.5, and then I'll use the number 2 when I get there. So if I put 0.5 in for x, 0.5 is a positive number. If I put 0.5 in for x minus 1, well, 0.5 minus 1 is negative 0.5. And if I put 0.5 in with x plus 1, 0.5 plus 1 is 1.5, so it's positive. So positive divided by a negative is negative. Negative divided by a positive stays negative. And finally, plug a 2 in. So I plug a 2 in for x, that's positive. I plug a 2 in for 2 minus 1, that's going to give me a positive 1, so positive. And plug a 2 in for x plus 1, that gives me 3, positive. Net effect, my graph is going to be positive. So now let's go. Let's put all of our important information on there, our intercepts, our asymptotes, and then we'll use our sign graph to see what our graph is doing at each of these intervals. So the first one we had was we have x-intercepts at 0, 0, and 1, 0. So we have an x-intercept there and there. We had a y-intercept at 0, 0, right? That was the only y-intercept there. We had a vertical asymptote at negative 1. And we had a horizontal asymptote. We didn't have a horizontal asymptote, but we had a slant asymptote at y equals x minus 2. So that just means y equals x minus 2, right? That's just like typical mx plus b. So it means my y-intercept is negative 2, means my slope is 1. So I'll do my best to draw this slant asymptote. Okay, and then I'm going to use my intervals to draw my graph. So, first off, being when my graph is less than x equals negative 1, right? When my x values are less than negative 1, my graph is negative. So that means when my graph is less than negative 1, I'm going to be down here in this asymptote, and I'm going to use the calculator to actually find that point. So let me get the calculator out, I'll figure out the maximum point there, and then we'll estimate how the graph goes from there, and we'll do the same thing over there. We'll find the minimum point over there. So I'll show you what I mean. Let me get the calculator out. So the calculator, I've already graphed our equation. That gives us this graph. You can see it's very similar. You can start seeing where the slant asymptote would be, where the vertical asymptote would be. I need to find this minimum and this maximum here so I can put them on my graph to the best of my ability. So I'm going to find my maximum first. Just go over till you reach the other side. There we go. And left and right and estimate. So that maximum point is negative. That maximum point is negative 2.4, negative 5.8. So let's see, negative 2.4, negative 5.8, not quite 6, so it's going to be right there. And then let me find the minimum over there. And so second calc minimum. Gonna go over here And we get that minimum point to be the point positive 4, negative 1.7, which makes sense. So it's just below the x-axis. All right. Now let's use our intervals to sketch the graph to the best of our ability. So when it's less than negative 1, right, when I'm on the left-hand side of negative 1, my graph is going to hug my asymptotes, it's going to reach that, and then it's going to go back down towards that asymptote. Okay, then let's see what happens at our next interval. Our next interval is in between negative 1 and 0, right? That interval was from negative infinity to negative 1. Now I'm in between negative 1 and 0, and in between negative 1 and 0, I should be positive. So in between negative 1 and 0, my graph is positive, and it's going to hug that asymptote. In between 0 and 1, my graph is negative. So in between, when x equals 0 and x equals 1, my graph is negative, which makes sense. That lines up with my minimum there. And then, for all values greater than 1, my graph is positive again, and it's going to hug that asymptote. Okay, so our sine graph gave us a pretty good idea of what our graph is going to look like. And here I have done it for you to show it a little bit better, just a little bit neater. But you can see that our graph gave us a really good sketch just by using that sine table. And finally, again, intercepts, asymptotes, sketch the graph. So, first thing, x-intercept. X-intercept is the zeros of the numerator, so this one gets kind of funky because we get 3x squared plus 2 doesn't factor. So let's solve for x. I get negative 3x squared equals negative 2, divided by negative 3, x squared equals 2/3, and the square root means we get x equal to positive negative square root 2/3. Okay, so those are going to be our x-intercepts, and that's about 0.82 to get you an idea of what square root 2/3 looks like. It's about 0.82. Okay, then we get our y-intercepts. Y-intercepts is what happens when we plug a 0 in. So negative 3 times 0 squared plus 2, 0 minus 1. That gives me 0 plus 2, so 2, negative 1 means our y-intercept is negative 2, or the point 0, negative 2. And I want to make sure I did the x-intercepts correctly. That would give me the point radical 2/3, 0, and negative radical 2/3, 0. Okay, so those are my x-intercepts. Y-intercept. Do not let the radicals confuse you. They're just a number. It's just a decimal, 0.82. Okay, then let's go through and find my asymptotes. So vertical being the first one. So vertical asymptotes, zeros of the denominator. My denominator was x minus 1, meaning my vertical asymptote is going to be x equals positive 1. That line. And then my horizontal, if I go back and look at my degrees, well, my degree in my numerator is larger, so I have no horizontal, but I'm going to have a slant asymptote. So again, I use synthetic division. Synthetic division gives us 1 because we're dividing by x minus 1, so a 1 would make that 0, and then we plug in the values for the coefficients of my numerator. Being negative 3, I don't have an x term, I have a constant. So this should be a review. Negative 3 times 1, negative 3, 0 plus negative 3, and 1 times negative 3 with a remainder of negative 1, but we're not worried about the remainder. This means we have a slant asymptote of y equals negative 3x minus 3, and now I've got all of the information I need to do my sine table. So my sine table, the critical numbers I had. Critical numbers, the first one I had was negative radical 2/3, which is about negative 0.82. Second one I came to was radical 2/3, about positive 0.82. And then my other critical number was 1. That's where my vertical asymptote was. So those 3 critical numbers for my x's. And then my factors are just x minus 1. And since the numerator didn't factor, I just put the whole numerator in there. So I get negative 3x squared plus 2. So now I'm going to pick a number in between negative infinity and negative 0.82. I'm going to click negative 1. I'm going to choose negative 1. So negative 1 minus 1 would be negative. And negative 1 squared would still be positive 1 times negative 3 is negative 3 plus 2 gives me negative. Overall net effect positive because a negative divided by a negative is positive. Now I'll pick a number in between negative 0.82 and positive 0.82. I'm going to pick 0. So remember here I picked negative 1. Here I'm picking 0. So if I plug 0 into here, 0 minus negative 1 is going to be a negative 1. And if I plug a 0 into here, negative 3 times 0 is going to give me 0 plus 2 gives me a positive number. So overall net effect, negative divided by a positive is a negative. Now I have to pick a number in between positive 0.82 and 1. I'm going to pick 0.9. When I do 0.9 minus 1 is still going to be negative. And when I do 0.9 in for my x squared, I get negative 2.43 for my first part. So negative 2.43 plus 2 is still going to give me a negative number. Overall effect, positive number. And now I'm going to pick any number larger than 1. I'm going to pick 2. So 2 minus 1 is a positive 1. 2 squared times negative 3 gives me negative 12. Plus 2 is a negative 10. Negative. Overall net effect, negative. So now I've got everything I need to go ahead and graph. Okay, so I knew my x-intercepts were roughly, really close to negative 1 and positive 1. I knew my y-intercept was negative 2. And I knew I had a vertical asymptote at positive 1. I also know I have a slant asymptote at the line y equals negative 3x minus 3. So that means my y-intercept would be at 3. And then negative 3 means I go up 3, left 1. So it goes something like this. Okay, and then go the other way. And do your best to draw in your slant asymptote. Okay, so now we've got all the information we learned from the first steps, just like from the last lesson. Next, I'm going to draw my graph. So I found, this minimum is just below that, so we can check that on our calculator to find that minimum. I'm not worried about being too exact right now. I just want to get us through these examples. I know there's a lot today. And then the other, so let's see. I forgot to use my sine graph. So from negative infinity to when I get to negative 0.82, I'm going to be positive. So that's why I had the graph going here, right? It's positive until it reaches that point. Then in between negative 0.82 and positive 0.82, I'm negative. So in between these values, I'm negative, right? The whole time I was negative. And then from positive 0.82 to 1, I'm positive. Right, I'm positive. And then for every value greater than 1, my graph is negative. And my graph is actually going to be the minimum or the maximum point is 1.6, negative 9.5. So it's right about there. and it's always negative, which it will be. It's never going to cross the x-axis, and it's going to hug my asymptotes. A lot of notes tonight, I know, but you're going to have plenty of time over the next 3 days, the next couple days, to get this nailed down. Go ahead and try the example problems. If you don't get them right away, no problem, but do your best, and we'll go over them beginning of class tomorrow.